So hello everyone, in this video we are going to start our discussion to the mathematics section of CSES problem set. The first problem is exponential. So in this task you have to calculate the value of a to the power d mod a to the power b modulo 10 to the power 9 plus 7. So let us see how we can do this problem. So we have to calculate a to the power b. So in the naive approach, what you can do, you can initialize a counter variable, let us say count, and initialize it to 1. Now you know that a to the power b is nothing but a is multiplied with itself b times. So the number of count of a here is b. So what you can do here efficiently, so you can apply a for loop which will go from 1 to b, right? And in each step you have to do one second. And each step you have to multiply count with a, and also remember to take modulo, and at last you can print the count. So this is the naive approach by which you can get a to the power b. So count will be having value a to the power b modulo 10 to the power 9 plus 7. But here you have to observe that the time complexity of this algorithm will be O of b, because you are running the loop b times. And you can observe here is that the range of value of a and b are from 0 to 10 to the power 9. So the time complexity can be up to 10 to the power 9, which can lead us to TLE. And we know that the complexity can at max be 10 to the power 7, or sometimes 10 to the power 8 is also accepted, but 10 to the power 9 is never gonna run. So we have to think better. So let us see how we can optimize the algorithm. So you can use the intuition of a to the power b is nothing but a to the power b by 2 into a to the power b by 2. Why so? Because in our school days you have learned that if a to the power x into a to the power y can be written as a to the power x plus y. So likewise, if we add these two powers taking base common, it will be a to the power b by 2 plus a to the power b by 2 plus b by 2, which is a to the power b. See that if we want to calculate a to the power 6, so it will be nothing but a to the power 3 into a to the power 3, right? But if you want to calculate a to the power 7, it will be a to the power 3 into a to the power 3 into a, because this addition will give nothing but a to the power 6, but we want a to the power 7. So again we have to multiply it with a to the power 1. So now this product will give us a to the power 7. So for even case you just have to multiply. If it is a to the power b, so it will be a to the power b by 2 into a to the power b by 2. But if it's odd, you have to multiply extra a with it, so it will be a to the power b by 2 into a to the power b by 2 into a. So you can recursively calculate the function f if it has two parameters, let's say a and b. So you will first calculate. So we know that if b equal to 0, so you can directly return 1, because any number to the base 0 will have value 1, and If it's not having base 0, you have to calculate recursively the value of a to the power b by 2. So let us suppose x is containing a to the power b by 2, right? So it will be storing function of a to the power b by 2. Now we also have to see if b is odd or not. If b is odd, then what you have to do, you have to make this as answer. So we can return x into a. Otherwise, if b is odd, means b is even, so we can return x into x. Remember to take modulo at each step. So when you have multiplied these two numbers, take modulo, and when you multiply these two product with a, again take modulo. So this function will give you correct answer, because you are multiplying, or you are calling the function only log of b times. So let's see why the complexity is reduced from order of b to log of b. So let us suppose we are calculating f of, let's say a is anything but b is, let's say 64. So now it will go to, first it will call a to the power 32, a to the power 32 will call a to the power 16, a to the power 16 will call a to the power 8, a to the power 8 will call a to the power 4, a to the power 4 will call a to the power 2, and a to the power 2 will call a to the power 1. So you can see that the power is reducing half of it every times, and we know that if anything is reducing half at each iteration, the complexity is nothing but that number to the log, so log of b. So it will pass all the test cases. I will show you the code. See what I have done. I have initialized a function f which will take two parameters a and b, and if b is 0 we will directly return 1. Otherwise we will declare a variable x which will be storing the value of a to the power b by 2. Remember to take mod. Now if b is odd, we have written x into x, means a to the power b by 2 into a to the power b by 2. Take mod, again multiply with a, again take mod. Now if b is even, we only need to multiply a to the power b by 2 into a to the power b by 2, as we have seen in the explanation, right? So this was the solution of the problem, because in every iteration of a to the power b we are finding the value of a to the power b in log n time. So if you have any doubt, you can comment me in the comment section, and I will happy to answer your queries. Thank you so much.